In this video, let's discuss another periodic trend, so a trend or a property trend that we can predict for various elements on the periodic table just based on their position. So ionization energy. Let's look at this periodic trend. Ionization energy is defined as the energy required to remove an electron from a gaseous atom that's in its ground state. So what we're doing here, an example, just a sample element, let's define it as X, and we remove an electron. Okay, when we remove the electron, we leave behind an ion. So ionization energy, the energy needed or the energy required to create that ion is what we're measuring here. The higher the ionization energy, the more difficult it is to remove an electron. So the electron will be tightly bound to the nucleus, attracted, I should say, to the nucleus. Now, ionization energy, you can have more than one value. You can have what they call the first ionization energy, which is the ionization energy for the removal of the first valence electron. And then if you proceed to remove a second valence electron, then that would be considered the second ionization energy. And if you proceeded to do a third, the third ionization energy. Now, there is a trend when you have a first, a second, and third ionization energy. That energy will show a steady increase, so to say. It'll always be increasing from the first to the second to the third ionization, because as you remove an additional electron, there is, each time you do that, there's going to be a greater effective nuclear charge. The nucleus is going to have a stronger attraction towards the valence electrons because the number of positive protons will outnumber the total of electrons that are negative. Okay, so let's look at the trend that we can discover on the periodic table regarding ionization energy. So again, ionization energy, the energy needed or the energy required to remove an electron from its from a gaseous atom in its ground state. Okay, and ionization energy would be an endothermic reaction because it requires energy to remove it. So let's think about this. When we were talking about atomic radius in the previous video, we realized that as we go down a column, as we go down a group, we notice that the radius increased because as we go down each period, we go down from period 2 to period 3 to period 4 and so forth. We increase those energy levels. The radius gets bigger, so the valence electrons get further from the nucleus. Well, if the valence electrons are further from the nucleus here at gallium than they are at boron, then the effective nuclear charge of the protons in that nucleus is going to be less, okay, as you get further from the nucleus. Because think about that. For example, if you have a dog and you take him out for a walk and you put him on a leash, okay, now as you're walking through the park, if you extend the dog's leash to 8 or 10 feet, then your dog has more freedom, okay, is further from its nucleus, so to say, which is you controlling it. So the dog has more room to explore, more things that it can sniff, more freedom to move about, okay, because it's further from its nucleus, from its control. There's less attraction to that nucleus. So it would be easier for the dog to have freedom and find a way to get away from you, so to say, to get away, to be removed from your control. Well, we see that with atoms. As the radius increases, we see that it becomes easier, okay, to remove those valence electrons. So we would say that as the radius increases, as we go down a group, a column, we see a lessening, a decrease in that ionization energy value. Okay? We see a drop in the value because the radius is getting larger. The valence electrons get further from the controlling positive nucleus. Okay? Now, when we look at the trend based on a period, now remember, a period is a horizontal row on the periodic table. If we reflect back to atomic radius, as we move across a period, we are filling up that energy level with electrons. Okay? So the radius is getting smaller because the nucleus is getting bulkier and getting more effective nuclear charge. Well, if our radius gets smaller as we move across and our effective nuclear charge increases as we move across, then it would appear that it becomes more difficult, more challenging to remove an electron. The ionization energy would be much greater on the right side than on the left side of this period. Okay? As we move across a period, the effective nuclear charge, that positively charged nucleus, and its attraction for those valence electrons increases. So if that increases, it would be harder to remove one of those electrons from the atom. It would be harder to rob one, to rip it away. So we see a decreasing an increasing in the ionization energy. It becomes much more difficult as we move across a period and as we move down a column, down a group.